That's the question. Back to the question. My question. So there is. So should I start? Can you mute that? Okay. Welcome everyone for the Learning Analytics Tools. Welcome everyone for Learning Analytics Tools Live Interaction 1. And today we will, talk about kind of revise what we discussed in last 3 weeks lecture, especially about what is raw data, what is feature data, because that is very important to understand what is the raw data and from raw data how to extract features and everything. So we'll quickly go revise what is raw data, feature data. And if there are any questions, we will take the questions at the end of it. Okay. So So I would like to reiterate. So I would like to again talk about what is raw data, because there's a confusion about raw data and what's the features and how to extract this and how do you get those data. So the first step is that what is raw data? The raw data is that a data which is collected in a raw format, like the data we collect. And before we do any data pre-processing, before we do any data extraction, no feature extraction, the data which we collect is a raw data. Raw data can be a human observation, or like a human is observing in a classroom and entering the recording some data, that can be the raw data. Or raw data can be the set of files or set of information log collected by set of sensors. For example, if you have a temperature sensor in this room and the temperature sensor is giving data about the temperature at every, say, 30 seconds or 1 minute, the data has been recorded with the timestamp and the temperature at every 30 seconds or 1 minute. That can be the raw data. So raw data can be the human recorded or the automatically collected from sensors. It can be handwritten notes. For example, attendance record. If you remember that in the schools, we might have the attendance record, a big ledger. It will contain all the names of the students and the dates. For example, here, for example, this is what the attendance ledger will look like. You know, the 8th of August, there are 2 absent days and yes, 1%. And like we can get the data about each student's attendance from this particular ledger. The raw data here is the handwritten in a notebook, right? So handwritten copy of the attendance. Or if you would have using the biometric data, for example, if you have biometric sensors in your university or in your place, and students are when they walk in, they are they are entering their bio ID, right? That data might record like this. Okay, it's not always like this. It might record the ID of the person and the timestamp and which course he is doing it. Suppose this is a course we offer, or some other course, or something like that. Which course? The learning analytics tools, or some other course it will offer. So from these data, this is the raw data. Raw data is how the human is taking the notes by handwritten notes, or by sensors is recording the data. For example, in the handwritten notes, if you go to the classroom, you are observing the students' engagement. You might be observing the students' engagement in the form of number of times they asked a doubt, the students asking about certain questions, or the reactions to some of the feedback given to them. So those things you are writing in hand, then maybe with the timestamp and details. Whereas that data is the data you collect, and now From this raw data, you need to process it. For example, in this attendance data, you need to convert this into digital format. After converting digital format, make sure that all the fields are filled. If some fields are not filled, make sure now to handle that. After doing that, what exactly you want to use it from here. For example, in this attendance data, I would like to know how many students are present more than 50% of the time. 50% of my classes. Like till midsem, I want to know I'm teaching. So 6 concepts I taught till now. Just a minute. So okay, sorry. So for example, for example, in attendance, I collected a data. I want to know it till the midsem, how many students have attendance more than 50% or 80%. That attendance data might give me some information. Or I want to know which class have highest attendance, or which class have the least attendance, and which day it is, something like that. Those information can be obtained from these data. So those are the features. So deriving values, the value we derive from this or features from the raw data. Okay. So I hope this is clear, the raw data. So after proper data pre-processing or data processing, we will construct features or we'll derive features. So list the features, you can think of now. What are the features we can construct from this simple attendance data? That's one way to think about it. And there's the small activity I might have given in the course also, like stop, fast forward, and think about what data we can collect in the classroom or in the daily environment or in the MOOC. So here's the example of what data we can collect in the classroom. For example, we can collect students' attendance in raw format. Are they coming to the class with 5 minutes late, so 10 minutes, that late time can be collected. Of course, we can collect the performance in the endsem, midsem, some topic-wise unit test, everything. And there's a LMS, learning management system. It can be Moodle, it can be Blackboard. This information log data can be captured. Or the profile data, like the student, which year they are studying. I'm sorry. Which year they're studying, or the background information, the gender, the age group, everything can be captured. Or if might be interested in the seating arrangement of the class. For example, which students sit in the front rows and which students sit in the middle or back. Or is the student sitting together always? Are they doing the project together? If they do project together, how are they doing? Something like that. Or the performance, you can map it. Or you can human observation, you can record the number of doubts they asked in the class, questions asked, a number of times they answered, or the posture, or the engagement, or the disturbing to others. All this information can be absorbed manually in a raw data format, then converted. These data might tell us about students' engagement. The seating arrangement might tell us about how the groups formed in the class. Profile data is the unique data, we get it. And LMS data might give us about how many times they log in, is the student is accessing the material in the periodic time, or is he taking time to, is he thinking about assignment at the last minute, like procrastinating till the end of. Those kind of information can be obtained here. So time taken to teach each concept, other activities for the teacher side. Like if you're taking more time, for example, I created a slide for 50 minutes, but I'm not able to complete. So a teacher should think about, okay, I'm not able to complete in such a time. Maybe I should spend more time. I should reduce my teaching content for students to understand better, something like that. So we can have a lot of information about students in the classroom data in the form of log data and convert into features data. So this is what I mean when I say about log data, raw data, and features. So, but if you see, just a minute. So if you see, there might be a bias in data collection. For example, if I'm collecting the data such as, like I've got data about the quiz performance in a MCQ quiz, like multiple choice questions, and the bias will be low. For why when we're collecting data in such environment, the students are answering, and you are actually converting, automatically grading them using some rubric, right? Easily. So you're not actually looking at the answers and grading them. If it is multiple choice questions, there's no bias basically. Bias is very low. But if you are observing the students, for example, if you are trying to rate their essay writing, if you ask them to write an essay or subjective answers, you ask them to observe, grade them based on accuracy or language correctness or presentation, or you want to understand the students' emotional state or affective states in the classroom, like are they bored, are they confused and frustrated? This depends on the human observer, right? If I observe some student is confused, the other human observer may not observe the student as a confused or bored. In those cases, to avoid this bias, what we have to do is we can have an inter-rater reliability. We can establish that when we observe the particular concept, or when we observe when you have the particular concept, or when we observe a student's emotional state, or if you are giving a rating for the particular thing, or if you are assessing some student performance, you might have bias. To check whether you are biased, ask the other researcher or other person to access it. Like you, when you're recording the student's assessment of the essay, ask one more person to do the assessment. And make sure both agree to the assessment rating. If not agree, talk to each other again, why the mark is such difference. Then discuss and engage, then resolve the issues, then again code again the new set of users, and make sure that you have at least a good inter-rater reliability. The inter-rater reliability is measured by using Kogan's kappa. So I think this week 3 we will talk about Kogan's kappa. I think Kogan's kappa is actually used for inter-rater reliability. That is how if Kogan's kappa of 0.8, then the both rater agree on something, so that can be used for research. So when you collect raw data, the raw data can be collected by post-performance can be collected directly by sensors or the manual observation. Or if you have to collect, you have to decide, assess, or observe something using your intelligence. Then make sure that you establish the interoperability. Okay, this is about raw data. So most data students collect in the classroom without the human observation are based on learners' cognition. We are trying to understand learners' performance in exam, or learners how they learn, or learners' attendance, or learners' behavioral engagement, like that. But it is not enough when you understand the students. When you understand students, we need to understand the students' self-regulated learning. What is self-regulated learning? When we are given a particular task, when we are given a particular task, we actually, before we start anything, we plan how to solve the task. Then we actually start thinking about how to solve the task. What are the materials I need to read for this task? What are the extra information I should consider? If I know some information, should I read more? Those things has to be thought well before we start the particular task. And when you are executing the steps, for example, you are implementing your task step by step. If you realize that, if you're aware that you are not going in the right direction, if you're not able to achieve the things we expected, you have to monitor it, and you have to replan your strategy. You said, okay, maybe the approach I'm using to achieve the task is not working. I should replan my strategy. This idea is mostly happens in mind. Okay, it's called metacognition. So it is thinking about thinking. What happens here is the process of how I'm planning, the awareness, it is not happening as the expression. It's all happening in the person's brain. So that is called metacognition. So in order to solve a task, we need cognition, we need affect, and metacognition. Affect in the sense, if I'm putting a lot of effort, for example, I'm putting, say, 10 hours to solve a particular problem, but still I'm not able to solve the particular assignment, and I'm not able to do well. If I really struggled hard to solve a particular issue, I'm not able to do it, I might, when the deadline comes, I might get frustrated, right? And when we are interacting with the system, sometimes we get confused, we get bored or frustrated. How people actually manage that? How manage and how continue doing it after getting those things? That is what we call it as affective states. It's not the emotion. It's like appears in 1 second or 1 moment. Affective states is like prolonged emotional state, like it occurs due to some other activities and everything. So when we call it self-regulated learning, it involves cognition, metacognition, affect, and motivation. This combination of these four constructs is called self-regulated learning. So why I'm saying this about this is that since we know that we can collect, we can create, we can derive features from the raw data. For example, from attendance, I can talk about how many students present on day one, how many students are present on day two, what is the ratio of students present on day one compared to day two compared to day three. Like that, I can create more number of features. But is the all the feature should be considered? Should we consider all these features? Should count the features in our study. This knowledge is come from the domain expertise. We may not need all the features. The features will have interdependency. So the domain expertise can be from the self-regulated learning. So we apply this concept of self-regulated learning. When we construct the features, we think about what this feature will tell about. This feature will tell about the student's learning process of planning, or this feature might tell me about the school learner's affective states. This feature will tell about learner's cognition. So when you construct or derive features, make sure that you have backup why you are writing, some reasons for that. That is very important. Okay. So since I talked about raw data in a classroom, mostly the classroom raw data is handwritten notes or observations, or sometimes in the Moodle data. But in reality, in the log data in the MOOC, I think you have seen this in the last week. In the MOOC data, we collect raw data like this, this is an even type of seek video, or it can be the page code. How do we convert this data to useful format? So the useful format can be, let's see, the process data. This is all in JSON files. So we need to create a session ID. If there's a session given, if there's a session given in this thing, it goes off, copy the session ID. And the user ID is here. You can copy the user ID. What action was, the action was seek video. The time, this is a timestamp, not the seek video time. It's a timestamp of when this particular action occurred. So you see that session ID, user ID, the action, time. The context can contain more information. In general, we don't use, the seek time or the seek from which time to which time. All those information, we will not use it in our analysis, because if you try to, train the system for such a finer data, you will not able to, generate a inference which can be applicable to whole class. You might be very global, very locally trying to tell how one student can perform this, and you cannot extrapolate it to all the students. So we actually stop our analysis with the action level data, but it's good to have a context. For example, if you find out one student is not really working well and you want to know why, then you can check those data, then you might find more insights about it. Okay. So when you get a raw data, please convert into these set of session ID, user ID, actions, and time. Then try to come up with the more, derive more features from this data. So that's all about raw data and the feature data. And as I mentioned, this is one of the format we suggest, to use the data, like user ID, session ID, timestamp, action, and context. And you can store in a different format and for analysis. Okay, that's all about raw data. If there are any questions, I think I'll take it. I think no one questions. What is the question in the Excel sheet?
How to collect this raw data?
Okay, so one of the question in the Excel sheet is how to collect the raw data from different learning environment. I think if it is a classroom learning environment, we can collect the data like a human observation, the performance and or the attendance or profile data, all this information. If it is in a tele environment, all the clickstream data can be collected. Like as you showed in the MOOC, when they log in, if they're reading some page, they are watching video or they're pausing, which speed they're watching, all this information can be collected. Those information can be extracted in such format like a user ID, session ID, timestamp, action, and context. Then with this data, you can actually create features like what is the average time a student spending on my video, like video one, what is the average time each student spends? How many times the students watch this? So that's why I mentioned two things in my slides, like a duration and frequency. The one is you construct features based on frequency, like number of logins in a week, number of sessions within a day, or number of times students attempted this particular quiz, or number of times student attended this assignment or something like that. And duration is how much time the student spent on each video, something like that. That is also collected. So in a real classroom, you can collect data by human observation. In the computer-based learning or tele, we collect data using all the clicks and traces in the system.
So one of question asked in a forum, can we get the open data to practice the learning analytics? Yes.
Okay, okay, if you are interested in open data, I would suggest go to Open University Learning Analytics Dataset. OULAD, Open University Learning Analytics Dataset. They have it's a open university in the UK, and they have collected data of how many thousand students I forgot.
More than that.
More than 1,000. Right? There are 8 courses, more than 1,000, more than I think around 10,000 students. I think 8,000, 10,000 students. I guess.
Yeah.
The 8 courses, not all students, it's all the courses, and it occurred across I think 2 years or 4 years. I forgot exactly.
It is 4 years. STEM courses are there, even the social science courses are.
So they have data of students interacting with the courses across 4 years, and each year have two offerings, like semester 1, semester 2. So we have 8 offerings of different courses. All the students records their interaction data and the performance, their assignment score, the computer-based assignment or the tutor access assignment. All this information was given to you. It's available in the website, Open University Learning Analytics Data. It's available in Kaggle also. I'm sorry, yeah. And this data set has been used to write several papers, at least 30 papers, till last year. So people are still researching on this data set and writing more on that. So if you are interested in working on it, it's an Open University Learning Analytics data set, which has all the profile information, also the students' interaction in the learning management system. Okay, then another data set is like go search education data sets in a Kaggle. Kaggle is the the data science competition website. Try that website and you find 2 more actually. One is from the competition test with several thousand students interacting with the system, and time they spend on each question also kind of captured that. Yeah.
So one more question asked in a forum, that is, what is academic analysis and a learning analysis?
Okay, I think this we started talking in a first class about learning analytics, EDM, and academic. So learning analytics, EDM, we are considering both are same. Okay, it's all same. But academic analytics is that when the administration, like the university head, want to know which course is very popular, or which course is more students are not joining, or and they have seen that if I combine multiple courses together, can I create a new degree or something like that? When the administration looking at the data and they're trying to make a decision at the administration level, that is called academic analytics. Learning analytics, we basically talk about within the class, performance of the class, maybe last 2-3 years or 2 semesters, and how one student works on it, how to understand one particular student's learning process. Very focused on one student or one class is learning analytics. Academic analytics is such a high level that like the 10 classes, which class doing well, or which course is doing well, or in a district there are say 1,300 schools, which school is doing good, or which school have all the resources, those kind of information. So that is like academic analytics. But actually academic analytics word has been replaced now. There's no academic analytics. It's called business intelligence. The corporates can do that. So we will not deal about academic analytics in our study. We only talk about learning analytics. That is how the students interact with the system in the classroom. Can we use the data to understand how they learn? That is our main focus. Yeah.
And one of the students asked about the tele. What is tele?
Oh, okay. So I think tele we talked about it in week 2. It's technology enhanced learning environment. For example, we develop the environment technologically enhanced. For example, I create a website, I add some 10 videos, I add in-video questions. Like when you're watching video, the question pops up, you're answering it. It's technologically enhanced learning environment. It's a learning environment, but with technology. The main idea is here to I'm sorry. The main idea here is how we can help the students to learn better. Can we use the technology to create a better learning environment? That is called tele. it can be a simple Moodle, okay, and LMS can be the daily, because learning management system is also, there is some technology to help you to keep all your content in one place. Or a set of videos created in a nice website, it can be also technology enhanced learning environment. But when we call about technologically enhanced learning environment in our system, what are we looking at is that we try to create an environment with with the goal of to teach one particular concept to students. For example, I want to teach the students say about force and distance and velocity, this physics concept I want to teach them. Then I'm giving this related resources to understand this relationship between force, distance, and velocity. Then I also give a set of problems for students to solve. You have to read these resources and do some simulation or place with something. Then you have to go ahead and solve the set of problems. So here in this technology enhanced environment, I'm giving the resources to solve the particular problem, also the method to assess whether you understood the problem or not, and also some kind of feedback. Okay, if the student is not struggling, there might be some message comes up. There can be agent. The student can ask, "Hey, how do I read it?" or something like that. Some instruction or some help or hint feedback is there. This is a technology enhanced learning environment for us. Why? Because we create this environment in a mind keeping that we want to conduct research studies and students interact with these environments. So we restrict the number of actions. We make sure the students is able to go through all the resources. They have freedom to interact with the simulator or something, and they have go and access the knowledge. If they're not able to solve it, they can come back and read again. Those kind of freedom we give, and we try to capture all the log data. That is the idea we do. So basically, Tele for us is technology dynamic environment. We create it to collect the log data. I think that's the question, right?
That's the question.
Yeah. So this is Jyoti, and Jyoti is one of the teaching assistants. And if you are getting the reply for email, if you have any questions, she might be the one who's answering it. So yeah, if you have any questions, please feel free to ask us in the, just wait. If you have any questions, feel free to ask us in the Gmail on the discussion forum. And yeah, keep learning and enjoy learning analytics. I think that's all about okay, sorry. I think that's all about the raw data. I think I'm going to go into the second topic, that is performance metrics, this week's topic. And in this week's topic, we will be talking about performance metrics. Please make sure that please make sure that what is precision and what is recall and why we need kappa. So to summarize, precision is about true positive given over true positive and false positive. Like if I am saying everything is true, for example, there in out of 100 students, 76 students will get more than 80% marks in the exam. So I'm thinking about that. But actually, there are only 60 students will get more than 76 marks or 80 marks. So 16 students, I did not do it. So if you think about this, for example, this is the way I predict. For example, I predict this pass because 80% mark is the one. If the students will not get more than 80% mark is 0. So then I'm saying that there are 3 students will get more than 80% mark. But only 2 students who got more than, actually 4 students who got more than 80 marks. But in that 3, only 2 are correct. Then I can say precisely, the system predicted 2 derivative plus 1, 0.66. In a recall, we actually try to check how much I was able to predict. For example, there are 4 students who got more than 80 marks, but I predicted only 2. So this kind of gives me how much my system can predict correctly. Okay, in the previous one, out of so many things I predicted as a positive, how many are right? In that, how many out of the really positive, how many I can predict? That's the difference in the recalculation. Please check this both, and recall and precision and also the accuracy, right? These information are useful to understand, to understand how your system, if suppose you are using a system, for example, decision tree or some system, the classification problem, and how your system can perform well. That is what the goal, in the precision, recall, and accuracy. But if the system, is actually, what do you say? If the data is really not balanced. For example, if I have a data of 100 students, in that 95 students pass the exam. For example, nowadays 90% students pass the exam. So I want to predict how many students pass the exam. If I simply say all the students will pass the exam without applying any intelligence, if I say every student will pass the exam, that will be like a 95% of accuracy, because you'll be predicting all students passing the exam, and the 95% accuracy, and precision is also around 95. Is that make sense? But there are 5 students who did not pass, and you did not even predict one of them, right? If you're not predicting them, how can you go and give feedback or something like that? So in a data like this, highly imbalanced, like 95 students pass and 5% fail, it's not correct to use only recall, precision, or the accuracy record. For that, we use kappa. So please watch the videos again, how to compute kappa, and check Wikipedia page about accuracy, recall, and precision, and it gives complete detail about this. So I hope you understand this, the parameter metrics. It's very important, because when you think about ML mods, and we always say that, so my system predicts 90%, 90%, but without understanding whether what is the data, is data is rightly classified, is data is balanced data. Without this information, telling someone that my system predicts 90% is not correct. So kappa score might tell you the real values there if you're predicting, or F1 score. So that's what I want to talk. So that's all for today, and thank you. Thanks for joining, and if you have any questions, please keep posting. We will talk about those in the next live interaction session. Thank you. Hence, please.